Okay, here we're going to talk about phylum Annelida. These are the annelids or the segmented worms. So I hope you'll never say just worm again. Never say worm again, because you now know there are flatworms, there are roundworms, the nematodes, and there are these segmented worms. And so it's kind of nice to know that there's so many different kinds of worms out there. And of the segmented worms, there are three main kinds. There are earthworms that you might find in your soil outside that aerate the soil. They're very useful. Leeches, which, you know, are not as pleasant but can be used in surgeries to clean up wounds. And marine worms, which have had a huge ecological impact in our planet's history. So in a moment, I want you to click on this video for the Aberranicola worm, or go through your Canvas site, just clicking through and you'll be able to watch that Aberranicola video and answer your questions that are in your notes. The video is 13 minutes, but you can just watch the first 5 minutes and 40 seconds to answer all the questions. And then we're going to move on to phylum Echinodermata, the echinoderms. These are sea stars, sea urchins, sea cucumbers, sand dollars, and the word echinoderm means spiny skin. And as larvae, they are bilaterally symmetrical. That's like we are, where we have two equal halves. If we were to divide ourselves in half, we would have a right side and a left side that's relatively symmetrical. But as adults, these guys have kind of converted back, you could argue back, to radial symmetry, which is what the cnidarians had back at the beginning of our lecture series. We talked about cnidarians, and they had radial symmetry, meaning you could cut them in many different planes like a piece of pizza. Oh, that's not a very good cut there, but that each side would then be symmetrical. So as adults, echinoderms have 5-part symmetry, and it's a radial symmetry, so it's kind of different. Let's look at the body plan of a typical echinoderm, a sea star. They have what's called a water vascular system, and that is sort of like their circulatory system. They don't have blood. They have instead this system of tubes that goes through the body that have water running through, bringing oxygen to every cell, taking up carbon dioxide from every cell, and also that water vascular system is connected to these tube feet, which you'll see in the video. Tube feet are used by echinoderms to move. These are tube feet here, and in a sea star, the tube feet can be used to create suction on a muscle that they then can pull apart the shells of this bivalve muscle, and then they can eject their stomach and digest the muscle inside. So they use their tube feet not just for movement, but also for opening up really hard to open muscles. So there's a video to watch on sand dollars off the coast of California, and you can see some of the cool things about them. And then that will conclude our invertebrate lab. So look on your next Canvas, on the Canvas module. It'll tell you what's due, but basically all these questions that you've been answering, I want you to answer it on the file, upload that file in whatever format works for you, and that's your lab is complete. So I hope you've had fun. I hope this has spurred an interest in invertebrates, because they are fascinating creatures, and you'll be able to find them in so many places. Okay, see you next time.